about the same thing for impact strength. There's the same amount of impact. And then for yield strength, it would be for amount of deformation on a plastic piece. So aluminum 80/20 is what our CU Denver expert advisors recommended us doing. They said it's a lightweight, durable kind of thing. We got a sample that they gave us, luckily enough. Our full muffin that we made out of this that you'll see later is about 5 pounds total. And you'll see, people have made previous projects with this stuff. There's a website that you can just buy the stuff off of. And what's so fancy about this stuff is you'll see these grooves in here. These allow for T-nuts to connect, and then you can connect more pieces all together and kind of create like a bigger model. It's also rust-proof, which is really nice, so you'll be able to use this for a very long time, basically like a lifetime warranty, if you will. And it's going to hold up well against high mounted work, which is what we want.
All right, so for my research, I had the application of physics originally, and during that time I was going to research some projects, if there was any that were sort of like ours, but I completely abandoned that idea, so Ryan could take it over, and then by doing that, I replaced it by taking over full control of the whole design process. And this also fits hand in hand with the cosmetic properties, and it's also applicable to the areas I wanted to go into, such as mechanical engineering and industrial engineering.
All right, so for my timeline, this is going to take a while, by the way. So the first week, we wanted to just get a basic idea of what we're working with. So we took some extra measurements of Harrison's wheelchairs, kind of like looked around, came up with some ideas, just brainstormed a little bit. And then the next week, Chris Thrupp actually recommended at first maybe look like a bus door mechanism that would allow for when we maybe feels like a basic motion like that for opening a bus door that would allow for the baseball bat to swing. This is an example engine of what I found online. That's not really going to be able to fit onto what we're trying to work with, unfortunately. And so that's more of a dead end. And then the third week, originally, I thought I was going to be using trigonometry. The more I looked into it, I was looking more at physics instead. And I just wanted to make sure that with the ideas I'm keeping in mind that this bat swing speed is fast and good, that it stays on the ground, and that's a fluid swing. It's not going to be like jerking back and forth at all. Continuing on, I thought I was going to be doing most of the designing. Aolani took that over, so I did some extra work. At the beginning, I did some logo helping and making the company name and all that. And then I was doing some more research by that point where I was researching ways that would not go too far, because with the clay pigeon thrower, it doesn't stop exactly at 180 degrees. It goes a little bit further than that, and I didn't want that to create any danger for Harrison. Next, we did some more measurements of Harrison's wheelchair just to get a better idea of what we were working with. And we also completed our job shadow down at CU Denver. I started contacting various people to get materials gathered. Jackson Seacrest got us the clay pigeon thrower for free, which is actually an $80 value basically, which is not good. Then we went out and got some more PVC pipe, things like that. And then I was also starting to gather some more materials by the week we got back after break. This is our second semester time. This is my second semester timeline. And I got the sample of aluminum 80/20, which we had, and got some more PVC pipe. And I also did some extra research just to make sure what we're using will actually work for what we have for our prototype. Continuing on, I thought the next 2 weeks were going to be preparing for major presentations. I wanted to actually do some catching up. So instead, I decided to do some more measurements, discuss more designing. I talked with my physics teacher about ideas to apply when doing the projects, because I knew what I was going to be working with, like rotational motions, things like that. She gave me the equations that I needed to use. And then after that, we were preparing major presentations the same year of presentations. So this all stayed about the same. For attaching the mechanism to the chair, I allowed myself 3 weeks for that, because with engineering, anything can go wrong and you want to make sure it works. And so you give yourself extra time just to make sure all that works. And I gave myself an extra 3 weeks after that to attach that to the wheelchair or to the mechanism instead. Just so I have extra time in case if anything goes wrong, I'll have more time. And I didn't actually have to take more time out of my own timeline just to make up for what I did wrong. And I also fit in some more meetings with my expert advisors just to make sure we're on track with what we need to do. Next after that, I thought I was going to be working more with the bat swing process and that it'd all be done. But by that point, we really didn't have anything, so I wanted to see what it would look like if we had our own type of model made with aluminum 80/20. So I did some more research, I found some drawings, and I was able to replicate that into SolidWorks, which is a 3D modeling program. And I was still working on that for about 2 weeks, and then I did a cost breakdown of all the materials that we would need, and found out it total to be about $400, unfortunately. And then after that, I created a wooden stand to simulate the wheelchair, because when we found out during some testing with the swing is that it wasn't very stable and wasn't put together very well, unfortunately. So instead we did a wooden stand just so we didn't have to attach it to the wheelchair and have any mistakes happen. And then finally, preparing final presentations and then presentation week. And an extra is a 3D printed extendable bat, which would just allow for some more mobility in case you just want to carry it in a backpack and just go to the fields whenever you want to. Couldn't really get to that point with all that I missed. So my reflection, I realized that my timeline had completely changed from the beginning. As you can see, there's a lot of green and red, nothing was just about staying the same. Because at the beginning of the project, our very first idea was just have a standalone device. And actually, the day of our initial project presentation, someone built that same device and it was on the news with Harrison, and we had to kind of change our idea completely because of that. Next, I wasn't allowed to complete physics applications because of some complications during the work, which I'll go to during pitfalls. I had to eliminate portions of the project, such as when we wanted to finish the swinging process, we wanted the baseball bat to drop off. So it was almost like he was in an actual baseball game and then build around the bases. Unfortunately, we didn't even have enough time to get around to that, so we had to really chop down what we had into smaller pieces and to make sure it was doable, because what we had at first was a very large project for us. And also I had to come to the realization that the first prototype may not work because I was getting very frustrated. But I mean, it is engineering. I had to realize that it's not going to work on the very first time, and that's why it's a cycle. And I just had to realize that it was not going to work because I was getting very frustrated with that.
All right, so my timeline starts on October 1st and goes to around the beginning of December. So for the first week, I was researching a bus door, as we said before, how a bus door works and how we were going to apply it to an actual chair or structure. And then I started making rough drafts and rough designs after that, but no calculations of any kind so far. After that, I allotted myself about 3 weeks to make the full theoretical plan. This was including calculations and everything necessary needed to make this thing come to fruition. And then for the next 3 weeks, I was going to split all the design work into SolidWorks between me and Ryan. But since I took over all the design work, that just fell on me, which I had no problem on. And then in there, I had to fit my job shadow within anywhere. And then starting on January, this is pretty much for the whole month of January. I knew I was going to have a little time for my SolidWorks, and I was going to see if I finished any. And if I had all of them finished, I was going to start assembling all the parts in the drawing, but not actually assembling the full physical structure yet. And then for the weeks after that, I was going to start my technical drawings. And then after that, I was going to do my mid-year presentation, start preparing for those, practicing, rehearsing, all that good stuff. And then I had an extra day to finish up drawings, but let's be honest, I didn't believe that. I'm sorry. So for February, for pretty much the whole month of February, I finished up drawings and I put printing parts because originally what we were going to do is start 3D printing all of our parts and start assembling them with like glue and screws and all that. But after meeting with our advisors, we decided not to print parts because it was going to be too weak and it was going to snap and it could cause injury to both Harrison or us. So we replaced that with building the actual mechanism out of PVC. So now we're into the month of March. I allotted about half the month for just cutting the PVC, getting it all sanded down, getting it all prepared, and starting the actual assembly. And pretty much from there on, I was assembling, gluing everything together, but there was no screws at the point, but you can see screws in here. There were no screws at the point because we didn't think that screws were going to be actually necessary. That's where I come to April. For that first week, we're going to test. And when I said the screws weren't necessary when we thought they were, that's why we're no longer testing on Harrison, because during the building process, I actually broke it. So I wasn't too proud about that, but we realized if it's gonna break during building, we're not gonna test it and possibly break during the test and possibly hurt Harrison. So we were just gonna test on our own and just reduce the risk entirely. Just if it hurts us, then it hurts us. And then from there on, we were going to prepare for the final slides and rehearsing and going over everything. So the reflection of my timeline, everything stayed fairly constant. Nothing, I never got really behind on anything too far. There were some points where I did fall behind, but it didn't take me a long time to get back up. There was never a time where I was like maybe a month behind or a couple of weeks behind. It was very minuscule errors that I had to overcome, which I did. And then, as I said before, I completely abandoned the physics and I commandeered the whole design process. So our final outcome was, what we wanted was a full swing structure, which we do have right here. But if we didn't have one originally, we wanted at least a complete theoretical plan with all kinds of drawings and all kinds of calculations. So if we wanted to continue this in the future, we actually could. We also wanted a quick release bat. Ryan touched up on it a little bit, and what he means by that is basically like in a real game where they drop the bat after they hit it. We wanted some way so he could actually drop the bat and run the bases. But we didn't get time for that because we didn't have enough time. And then, so we wanted to create a future marketplace application for this. So we wanted, as I said before, we didn't want it just so it was for Harrison. We wanted it so we could go to different people and have them, if they had the same issue, apply it to them, or someone can help us with the design process and make it probably better. So this is our final PVC concept, as you can see from right here. But this is what it is. These are clasping grams. Hey, that's a fun word. Clasping grips. These would be the actual clasping arms that go onto the wheelchair. But since we didn't test on the wheelchair, we had wooden structures that these clasp against to simulate what it would actually be like on the wheelchair. And this is the entire support structure for the play Pigeon.
So I worked on this on SolidWorks. This is a model that I made. This total is about $400 itself. These really big pieces you see here, all of these combined, that's about $184 total. This is about $60 here, so you can see it stacks up a lot when you take into amount of cost. We really didn't have the money for this kind of stuff, but I figured I'd make this just in case if somebody did come along with the idea that they could do this and that we'd already had it set up for them to do. Another thing is that these right here, these would screw into those rods that Aolani was talking about, and so that would actually allow for a little bit more variable angles when he's trying to swing the baseball bat. So a lot of problems we've encountered. The materials we needed, we wanted something that was strong and durable, but also cheap because we're high school students on a budget. So we weren't really able to go with the aluminum 8020. We went with just PVC pipe because it's durable and easy to work with it with the machines we had back in the tech shop. The mounting the device, so we weren't allowed to modify a chair whatsoever. It's about a $5,000 chair, they told us. And so we weren't really able to touch it, so we had to do something that was just attached to it, and then maybe they could just take off of it. General design, we really had no idea where to start with this. We thought first we were going to have like a sleeve that would fit onto his arm that's doing a baseball bat for him, and then we thought maybe we'd have just something that would throw a ball for him, and so we just came to this idea of something that would attach to his chair. The pigeon thrower, so the original spring on this, the black spring, that is a lot stronger than the silver spring you'll see here. That's where I came into problems with my physics concepts, because if you see here, that bends easy. This is not bending at all. And so I hung 80 pounds of weight on that with a leather belt, and I was trying to take a spring constant by having that stretched out. I hung 80 pounds, and what happened is that the leather belt snapped on me, and so I realized I had to completely abandon that physics end of the project. And so this is our testing video that we did. We got like 1 or 2 really good tests in there. It's not going to turn out too well, as you'll see. So yeah, you see it kind of falls apart, not exactly what we wanted to have happen, but it's a good start for us. If we had more time, we'd obviously work with the rods a little bit more in the chair, just get exact measurements of those and combine those graphs a little bit more to fit that size of the wheelchair. You have to.
Oh, there we go. So what was our purpose basically besides create this project? There was a lot of purpose, just building something, helping us out. But also there's a humanistic value, which a lot of people sometimes don't realize. It's not just, mindless engineers building doodads in the lab. There's a human component to it. It's like, as I say up there, it's helping us, helping others. And what I mean by that is, by helping Harrison, it kind of challenged us to go out of our comfort zone and do something that we weren't really comfortable with, and we weren't really sure where it would go. So by that, it's a unique experience that you can't really replicate. And by that, we got to help a fellow student, which it's nice to do because it's not like a partner thing. You got to conform to his needs while also challenging ourselves, like I said before.
And one more thing on that, engineering, people think that's all just about the math and the science. People don't really see that there is a human side to this. Working with students like this is really beneficial to the community. Engineering, people think, just work on computers all day, having fun with that. No, there is working with people and getting to understand their needs and what they want from the project as well. So, if you guys haven't really seen that side of engineering, I would like you guys to kind of think about that, because seeing the human side is really important to engineering with projects like these.
That's the end. Thank you guys for coming out. Any questions?